So, we covered quite a bit of ground yesterday and added quite a bit of code. And as I said, I continued to implement the get hand operation so that the controller could send the hand to the view to present the dealer's hand and to present the player's hand. And the console then simply iterates the cards in the hand and prints the value and the color so that we can have a display the hand of the dealer and player. I've also added a little bit of nicer, or what you could say, at least more obvious user interface maybe. So if we run it, it looks something like this. And if we play, we can see the dealer hand. He has 5 of spades and hidden of hidden. That will be okay for now. The player has 7 of hearts and 4 of spades. And then the main menu is presented again. So I think that's fine for now at least. So, and we can quit, of course. I also updated the sequence diagram. I think it's possibly best to look at it as an image. This is also posted in the on the course homepage under the 7th lecture. So I added this little alternative flow because this is kind of like the scenario that we are doing right now, so we should focus on this. And this is typical when you do a sequence diagram, you do it for one kind of like path through the code or one scenario in the requirements. So in this instance, we wanted to do the start new game scenario, and this means that this function wants to start new game, returns true, and this is the scenario that we are focusing on. It could also be that we start actually the sequence diagram in this alternative flow immediately. So we assume that, well, this stuff that has happened before has already happened, and this is the scenario we're focusing on. Depending on how many sequence diagrams we do, so maybe we do one sequence diagram just to show the how system events are handled, for example, in the controller. Then we could just list all the alternative flows here. We have this start new game, we have quit and hit and stand and so forth. And then we could add a reference to other sequence diagrams that explain stuff in more detail. However, this seems to be part of the paid functionality in web sequence diagrams, so I won't do that. Also, you could see, well, this looks kind of like the same that we had before, and this is possibly the new stuff. Present dealer hand, that goes to the view, and the view in turn calls an internal function, present hand, with dealer text and hand, and we loop over the all the cards in the hand. We get the value and we get the color, and that's it. And then we do the same thing for for the player. And also, this is some kind of redundancy in the diagram that you could remove and put in a separate diagram and just use a reference, just like you can use a function call. So you should avoid redundancy, of course, both in your code and in your diagrams, because having redundancy means that you need to change in a lot of different places when stuff change. So if you have a tool that supports good linking, And if we look at web sequence diagrams, I think they do support it, but it's a paid premium options. Yeah, you have it here. You can do a reference. This call is a reference to another sequence diagram. So, any questions so far? Everything is crystal clear. We actually have one small thing left. Next slide. Each diagram requirement has one sequence diagram. Well, at least one when doing modeling in this, when doing design this way, as the author in the book recommends, that is, you take a requirement or part of a requirement, and then you make a sequence diagram to find out how objects need to collaborate, send messages to each other, and to fulfill the requirement. And then you kind of like implement and make a class diagram out of it. Then you get sequence diagrams for a lot of your requirements, of course, at least in the beginning. So then you maybe won't have one sequence diagram per requirement or scenario, but at least a few of them will have sequence diagrams if you use this method. As I said, I'm not used to making sequence diagrams before I kind of like design. I'm often designing using class diagrams, and then maybe test drive the class diagrams using sequence diagrams instead. So you can do it in opposite ways also. But the method in the book as presented has some advantages, especially that you don't design ahead too much, but you stay focused on the requirements at hand. There is a tendency to over-engineer stuff if you kind of like just look at the class diagram. Oh, we could do this and then this, and maybe we should have this also, and the design may become overly complicated and support a lot of stuff that is actually not needed. So he has a point, I think, by doing at least a few sequence diagrams before we delve into the class diagrams or implementation. Yes, but we have one small detail left here. The score of the hand should also be presented. And this is an interesting requirement, actually. And I asked you yesterday to think a little bit about this. So do we have any ideas on where to put the responsibility of handling or having or knowing about the scores or being able to calculate the scores of the dealer hands and player hands? Any ideas? Inside the hand? Well, yes, of course. We need access to the cards that are in the hand, at least. So this should point us in the direction of adding it to the player and dealer then. Because right now the hand is just, well, it's just a linked list of cards. One alternative would, of course, be to look at, well, each card has a score. So maybe we should put the score inside the card class. A score attribute here, then the card knows its score, and we can quite easily calculate the score by just using this. This could indeed be a possibility. Do we have any other suggestions? Yeah, score is in some way at least dependent on the value here. So, but we could add a function get score that uses the value in some funky way and then returns the score for the card. All right, the next suggestion is to add it to the controller. And indeed, the controller is the one that needs the total score in some way. So adding a function here to compute the total score and of a hand and then giving it to the view could be one possibility. Maybe we should write this down. So add the deck. So maybe we have these alternatives. We could put it in the view also, as well as we have it in the controller maybe. It's actually, right now, it's only the view that needs these scores to display it. And it already has the hands also, much like the controller. So, yeah, we have a lot of alternatives. Which one should we go for? And kind of like why? And how should we try to think when we have kind of like a problem like this? It's not that obvious maybe where to put the this responsibility of scores and calculating the scores of a hand. And well, we have a lot of options. Yeah, we have some interesting ideas here. Well, we can first take a look at our architecture and use that as a guideline. So the architecture says something about where to put business logic. So we could decide if are the scores part of the business logic, the rules of the game, or is it simply a visualization or something that is used for interaction? Exactly. So the score, well, if we look a little bit further in the requirements, we need to decide who wins, for example. We need to know if the dealer has become bust or if the player has become bust. So there are a lot of rules that are dependent on being able to calculate the score. So this kind of like rules out these two alternatives. So adding the computation of scores to controller or view would break the architecture, because then we would have added business logic to the user interface. And that is a no-no. So we have three alternatives left then. We could add the individual scores to the card class or do some functionality there that given a value returns a score. Is that a good or bad idea? Yeah, we could have a separate class. Indeed. Okay, let's just take him from top to bottom. Adding the scores, individual scores to the card class. Well, it has the advantage that, well, the card knows the information needed. It knows the value of itself, so it could be able to compute a score. However, scoring in Blackjack is not just simply that because of the ace. The ace can have two values depending on how the score of the hand, how high the score of the hand is. Because if the player goes bust, the value of the ace can be counted as 1 instead of 14 or 13 or whatever. So this makes it a little bit more complicated to add the scores to the card class. So it seems that we don't just need the value of the hand, the value of an individual card to compute its score, but we need the total value of the hand to be able to compute the score of a card for the ace in the ace case. So that kind of like is a drawback of that way of thinking. And also, this would make the card kind of specific to blackjack. We could imagine that, well, this card class it's quite reusable right now. It's a generic card class, and maybe we are in the business of doing card games, and in the next project we would like to reuse this class in some way. And then adding the blackjack scores to the card class would make it very specific to blackjack. And we would either need to remove that part of the code, and that could be complicated and bad, or we need to kind of like re-implement, and that is also kind of like bad. So in this case, I think both of these issues with adding the individual scores to the card class is bad enough to not warrant doing this. Adding computation of scores to player and dealer has access to the hand. I think this is currently a good argument for adding functionality into the player and dealer. Could have the drawback of making player and dealer quite specific for blackjack. On the other hand, well, the dealer at least already is, because it already has some kind of rule implementation in it. It has the rule of how to start the game right now, to deal 2 cards to the player and the dealer, and one of the dealer's cards should be hidden. So I can't find any real drawbacks for this one. Add computation of score to deck. It's already dependent on cards. However, deck does not know about hands, and I think this is the major drawback of this. Suddenly we would need to add some kind of dependency. The deck suddenly needs to know about hands in some way, and this would add complexity and dependencies for the deck type. And the deck type currently is quite also reusable and generic, and could be reused. Add a separate rule class to compute the score. Indeed, I think this is something that we could do, so that the player and dealer has access to this rule class instead of being able to compute the scores directly. A possibility, indeed. Maybe it's a good thing to do, but I will just say that it's a little bit of an overkill for now. I would not mind actually that solution at all. Especially it has advantages because we could then plug in different ways of calculating the scores, and maybe have different types of games even, and possibly have a goal to reuse both dealer and player in the long run by plugging in different types of rules, because many card games have dealers and players in them. But the dealer is already quite specific for blackjack, so because we have already added this rule of how to start the game in the dealer class. So This kind of like leaves us with adding this computation into a player and dealer. Do you agree? Okay. Well, and it's kind of like information expert. The dealer and player are the classes that has the information needed. So, cool. And I have prepared, because this code is, well, it's not complicated, but it's at least a slab of code that just would take time to add. And basically, I add an array with the different card scores. 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 10, 10, and 11 for the ace. So that was the score of the ace. I also make sure that this array size matches the number of cards in the enumeration that we have. So if we in some form invent a new card or something like that, well, the code will break, so that we know that, okay, we need to add a score here also. Because this is something that is always a bit messy, that changing something in some part of the application, adding a new type of card, will break code somewhere else, because we have a dependency actually, but it's kind of like hidden. And in this code we have we are dependent on that we have a score for every type of card there is. And in Java, there is unfortunately no way to do this at compile time, as far as I know. In other languages, you can make the array to have a fixed size, and this size could be the count of the enumeration. But so the next best thing is to do it at runtime. An even better way would kind of like be to have an automatic test that you always run and check that this is the case. So you put view and controller under user interface. Indeed, the controller and view are part of the user interface. So there should be no business logic or rules actually in the controller or in the view. So the view can of course have data and stuff in it, but it should be data that is used for visualization only. And the controller could indeed have data and functionality in it, but it should be data and functionality that is used for user interaction, and not something that is part of the business rules. And for example, if we were to add the score calculation inside the controller, well, later when the dealer needs to know if it has won or not, it would need to call this code, and suddenly you would have a dependency from the model into the controller. Or you would have code duplication, and that is not a good thing, either of them. So, yeah, then we iterate the cards in the hand, and we get the value, and we index the score array, and we add the score, and we have a variable here, max score. I think I will just code it to 21 for now, because that is the maximum score that we can have. Then we loop through the hand again. And if we have an ace, we reduce this value by 10, so we just keep 1. So we can calculate our score this way. Det, it should be get. Seems that I had the wrong finger on the wrong key. So I think this will compile, I hope. All right, so now we can compute the score for the player at least. So let's add it so that we can see that it works. Let's just add 0 and a player get score. And the view. Maybe something like this. So we should be able to see the score now also, at least for the player. Get score, wasn't that the name? Calc score. Get score. So, all right, let's take a look at it. $17, 7, and the Queen of Hearts is 10. So that seems to be okay. Yay. Oh. This is actually something that we have not been that seems to be okay also. Have done is to, well, we can just play and play and play and play here also. And that's kind of interesting, and it's probably something that we need to address. But that seems to be working, so let's add it to the dealer also. And the dealer has a hidden card, so we don't know what it is, but that seems to be working. And we have two 10 valued cards here. And let's just take another test drive. 3 and 18. Yeah, seems to be working. So maybe our first kind of like requirement is more or less done. We could maybe do something about the ability to play a new game over and over. And what I will do is basically, for now, let's do it like this. Instead of doing this, stuff here. Let's do it when we start a new game instead. And we should probably also clear the hands of the dealer and player. Did it compile? Seems so. Eight and 4, 12 and 6 of hearts. Now we have 4 of clubs and king of spades, king of hearts. 8 of diamonds, 2 of diamonds, ace of hearts. So then we have 11 plus 2, knight. Oh, 21. So, it seems to be working, it seems to be quite easy to test. So, we're good, I think. First requirement, kind of like done, or third requirement maybe done. We have done the whole deal cards scenario. We have taken the top card from the deck and given it to the player and to the dealer respectively 4 times, and the last time the card remains hidden. And we have displayed the scores of the dealer and player and their hands also. So I think it's time to make a class diagram for this so that we can see how the classes actually are structured and how they are connected. So you could do this for yourselves during the break if you have the time. And we will do it together after the break. Any questions? All right, let's take 15 minutes of a break, and then we will return and create a class diagram giving the design and the code that we currently have implemented.